Alright, so today we're going to talk about the mid-segment theorem. So you have this green handout. There's actually two foldables per handout. So just go ahead and cut this in half. So cut it in half, give one to your neighbor, and then you're going to fold it in half like a burrito or like a hot dog. So then this is your little foldable here. So again, I know this is kind of blurry to see, so I'm going to go ahead and put my notes on a separate sheet of paper. So the first thing that we're talking about is the mid-segment. And a mid-segment is a segment that connects the midpoints of two sides of the triangle. So here we have a triangle. What we need to do is we're going to take a look at the midpoint of two of the sides and connect them. And that is the mid-segment. The mid-segment is also going to be parallel to the side of the triangle. So it's parallel. And then the mid-segment theorem so there's our mid-segment. It connects two sides of a triangle, is parallel to the third side, and is half as long as that side. So, if the mid-segment is x, then the base of that triangle is 2x. Or, if the base of the triangle is x, then the mid-segment is half of x. And that's what we're going to take a look at today, are these two theorems. So let's take a look at example 1. We have triangle ABC, and points X, Y, and Z are midpoints of each side. We can go ahead and connect the midpoints. And we get another little triangle on the inside. So let's take a look at part A. Segment XY is parallel to what segment? So here's XY. What is it parallel to? A to C. Parallel to segment AC. Part B. Segment CB, so CB is the side of the outside triangle, is parallel to what mid-segment? It's going to be ZX. Part C. If ZY is equal to 6, then AB is equal to what? Okay, if ZY is equal to 6, what's AB? Well, if we know the mid-segment, then to get the base, we double it. So 2 times 6, that's equal to 12. Sorry, 6, we double it to get AB is 12. Part D, if CY is equal to 7, then ZX is equal to what? So here's CY, is 7. Okay, remember point Y, that's a midpoint on this right side of the triangle, so that means that this is also 7. So this entire side is 14. Okay, the question is, what is ZX? Well, if we know the side of our triangle, then we take half of it to get the midsegment. So we're going to do half of 14, which is 7. And then part E, if AC is equal to 18, then what is XY? I'm running out of colors here. Let's see. AC is 18. Corresponding midsegment is XY, so if we know the whole side, that means the midsegment is half of that. So half of 18 is 9. So XY is 9. So let's take a look a little bit more of an algebraic approach here. This is 2A. So we have this large triangle DEF, and then we have midsegments of two sides giving us that midsegment of RS. It says if RS is 4x plus 5 and DE is 3x plus 25, what is RS? Okay, so if we take a look at our midsegment, it takes two midsegments to equal that base. So 2 times 4x plus 5 has to equal 3x plus 25. So to solve, we're going to distribute 8x plus 10 is equal to 3x plus 25. Subtract 3x from each side, so we get 5x plus 10 is equal to 25. Subtract 10. 5x is equal to 15. Divide by 5, and x is equal to 3. But remember, the directions are asking us to find RS. So RS is 4x plus 5. So 4 times 3 plus 5 is 12 plus 5, which is 17. All right, last one. We're going to take a look. I'm just going to redraw this picture. Again, we have triangle DEF, segment RS. DE is 2x plus 12. RS is 2x minus 2, and we're looking for DE. So again, how do we go from a midsegment to a base? Well, we have to take twice the midsegment. So 2 times the quantity 2x minus 2 is equal to 2x plus 12. So to solve, we're going to distribute Then we're going to subtract 2x. Add 4 to each side. Divide by 2, and x is equal to 8. Again, make sure you read the directions. The directions ask us to find DE, and we know DE is 2x plus 12. So 2 times 8 plus 12 is 16 plus 12, and 16 plus 12 is 28.